Okay, in sections 3, 5, and 3, 6, we're going to start taking a look at this idea of a ratio and proportions, okay? And we're going to look at how to write ratios, proportions, and also how to solve them, okay? But first, before we get into that, just a few basic things that we want to know about a ratio. First of all, a ratio uses division to compare two quantities, okay? The ratio of two quantities, A and B, where B is not equal to 0, can be written in three different ways. We can write it in words, okay? So we can write it as A to B, we can write it as A colon B, or we can write it as a fraction A over B. Most of the time in our course, we are going to use the fraction because it's just easier to kind of use in mathematical terms. Each ratio is read the ratio of A to B. Okay, so no matter how I write it, you would still say the ratio of A to B. And we really want the ratios to be written in simplest form. Okay, ratios should be written in simplest form. So obviously, if you can reduce it, reduce it. Okay. So just some quick examples of ratios and how we might use these things. If I take a look at the first example here, it says a person makes 6 long-distance calls and 15 local calls in 1 month. Find the ratio of long-distance calls to local calls. Okay, so because of the way that's written, I know I have to do long distance on top, local on bottom. Okay, or the long distance comes first, local comes second. So what I could write this 3 different ways. I could say 6 to 15, 6 to 15, or the way that I'm going to write it, and that is 6 to 15. Now you'll notice this thing can be reduced down. Okay, 3 goes into both guys. Okay, so 3 goes into 6 twice, 3 goes into 15 5 times. So the actual ratio would be 2 to 5. So in other words, for every 2 long distance calls, they made 5 local calls. Okay. The second part says find the ratio of long distance calls to all of the calls. Okay, so again, the long distance calls does not change. It's still 6 long distance, but now the total number of calls is the local calls plus the long distance. So that's 21 because we were 15 and 6. So it's 6 over 21. I'm going to reduce that down. 3 goes into both of them. 3 goes into 6 twice. 3 goes into 21 7 times. So 2 out of every 7 calls were long distance calls. All right, that's what that's saying. So again, just a couple basic examples of where ratios could be used. All right, and again, we'll kind of look at some more here as we go through the notes. The second example says Sean and Myra are selling tickets to their school's talent show. Sean sold 36 tickets, Myra sold 44. Find the specified ratio. The number of tickets Sean sold and the number of tickets Myra sold. Again, I'm just going to go ahead and write this in fraction form. Okay, so Sean sold 36. Myra sold 44. We have to reduce it. 4 goes into 36 9 times. 4 goes into 44 11. So you could write your ratio as 9 to 11 like that, 9 to 11 like this, however you want. Okay, it's all the same stuff. Okay, in part B, we're going to look at the number of tickets Myra sold to the number of tickets Sean and Myra sold. In other words, the number of tickets Myra sold to the total number of tickets sold. All right, so Myra sold 44. And the total number of tickets sold is 44 and 36, which is 80. And again, 4 goes into both of those. 4 goes into 44 11 times and into 80 20 times. So 11 out of 20 tickets were sold by Myra on average. Okay, and so that's just kind of a brief introduction into what ratios are. Okay, now really where we're going to spend much of our time here in these sections is dealing with proportions. Okay, and what a proportion is very simply an equation that states that two ratios are equivalent. Okay, so it's proportion is an equation that states two ratios are equal. Okay, and so remember how to solve a proportion, and you should hopefully remember this. Okay. If I want to solve a proportion, cross multiply. Okay, so in other words, if A over B equals C over D, remember, and hopefully again this is review for you, you kind of did one of these, A and D, and B and C, right? So what you would do is you would say A times D equals B times C. And that's how we're going to solve proportion. So when you set up a proportion and solve, you're going to cross multiply. So now just kind of looking at that, a few examples here of cross multiplying. Very straightforward examples, 3 and 4. Okay, so I'm going to go ahead and buzz through these rather quickly. If you want, you can go through and pause the video at this point and just use the video to check your answers or however you want to do it. So I'm going to cross multiply here. Okay, so I get 5 times x equals 15 times 3, which says 5x equals 45. Divide by both sides by 5, so x is equal to 9. Okay, x equals 9. When I cross multiply in part B here, now you got to be careful because when I do this, right, that 6 times y minus 2 equals 3 times y, and you got to distribute. Okay, so 6y minus 12 equals 3y. However you want to do this, subtract 6y from both sides. So you get negative 12 is equal to negative 3y. And then to get y by yourself, you're going to divide by negative 3, which says that y is equal to 4. Okay. And again, when you plug 4 back in, you can check your solution to be sure that you got it correct. All right. Same idea here. So I'm going to let you guys go ahead and do 4A and 4B on your own. I will do 4C with the anticipation that you're going to pause the video, do it, and then use the video to check it. So when I cross multiply here, I got to distribute the 10 to both things. So I get 10x minus 50. And then I got to distribute the 3 here, so I get 3x plus 6. Okay, subtract the smaller variable from both sides. That keeps the coefficient of x positive. So 7x minus 50 equals 6. Add 50 to both sides. So I get 7x equals 56. And then divide both sides by 7. Says x equals 8. All right, and again, A and B are very straightforward. All you have to do there is cross multiply and then solve. So you guys can kind of work through those on your own. All right, now we're going to get into some more application type problems, okay? An empty swimming pool is being filled with water. After 5 minutes, the pool has 400 gallons of water. If the pool has a volume of 11,200 cubic gallons, or I guess just gallons, how long does it take to fill the empty pool? Okay, so first you have to understand this, okay? So after 5 minutes, there are 400 gallons. And the question is, how many minutes is it going to take to fill up 11,200 gallons? And so now we set up a proportion and we just solve this thing. Okay? Setting it up, in my opinion, is the hard part. So you cross multiply. 400x is equal to 11,200 times 5, which is 56,000. And you divide both sides by 400. And when I do that, that tells me that x equals, let's see here, 56,000 divided by 400 tells me it is 140 minutes. Okay, 140 minutes. So just over 2 hours, 2 hours and 20 minutes to fill the pool. An Olympic-sized pool has a volume of 810,000 gallons. If it is filled at the same rate, how long will it take to fill the pool? So same thing on this side. It takes 5 minutes to fill 400 gallons. So the question is, how long will it take to fill? Now we're talking 810,000. That's a lot of water. Okay. So when I do this, I cross multiply. 400x equals, now I got to do 810,000 times 5, which is 4,050,000. Divide both sides by your 400, just like you would any other problem. And that tells you it's going to take you 10,125 minutes, okay, which is clearly an extremely long time. Okay. All right. And the last thing we're going to look at now, as we get ready to conclude here, is this idea of a scale. Okay, or a scale drawing. And this is going to be, ratios are going to come into play as our proportions here when we talk about scale drawing. So most of us are probably familiar with what a scale drawing is. It's just a matter of how we're going to use these scales and apply them. So let me just kind of finish erasing here. All right. So the last example we're going to look at, what is a scale drawing? Okay, a scale drawing is very simply a two-dimensional drawing of an object in which the dimensions of the drawing are in proportion to the dimensions of the object. Okay, so a map, things like that. Okay, so I'm going to this is a two-dimensional drawing. Okay, so it's 2 dimensions, and I'm just going to kind of summarize here. Okay, so it's a two-dimensional drawing where dimensions in drawing are, I'm running out of room here obviously, are proportional to dimensions of actual. Okay, so the scale might be, something like 1 inch is 1 mile or something like that if you're talking about a map. Okay. A scale model is a 3-dimensional model of an object in which the dimensions are in proportion. So scale drawing is 2-dimensional, scale model, same thing, but 3 dimensions. Okay. The scale of a drawing is the relationship, okay, so scale, relationship between scale and a scale drawing or model and actual dimensions. Okay, so the scale is the relationship. Okay, and clearly the easiest example in life, right, is going to be a map. Okay, clearly when we draw a map, that's all, those are all scaled out. Okay, this many inches equals this many miles or whatever it might be. Okay, or you think of a globe, right? A globe is they're all in proportion. All of the countries are relative in size, but clearly scaled down on a much, much smaller scale. So example 6 says an architect creates a scale model of a school. The school is 50 feet high. The ratio of the model to the actual is 1 to 75. Estimate the height. So the scale is 1 foot to 75 feet. Okay. The 1 foot is the model. The 75 is the actual. So the question is, how tall is the model when we know the actual is 50? Okay. And again, here's your proportion. Cross multiply. 75x equals 50. Divide both sides by 75. That tells you that x is equal to 2/3 of a foot. Okay, so the model is not even 2/3 of a foot, the height, which makes sense, right? A model is going to be smaller, much smaller. Part B says, suppose the ratio of the model. So now all they've done is change this ratio. Okay, so now instead of 1 to 75, we're looking at 1 to 100. Okay, and the height is they still said the height is 50 of the actual, not of the model. Just make sure your pieces line up. So we want to know the model when the actual is 50. Cross multiply. 100x equals 50. Divide by 100. So x is equal to 1/2 of a foot. In other words, it's 6 inches tall. So again, I know some of this is probably review. Hopefully most of it's review. We will use this idea of a scale and scale drawing and use it to set up real world examples and solve problems. So as always, any questions that you have regarding scales, proportions, or ratios, bring them to class and we will be sure to address those first thing.